Okay.
Good morning, class, and welcome to the Stat Garden. Today we will be talking about a new topic, the subject of residuals and nonlinear transformations. One important part of linear transformations is understanding residuals and residual plots. Residuals are vertical differences of a point from the LSRL, so y hat minus y, and we plot these error values on what is known as a residual plot. If the residual plot appears to have a pattern in the points, then we must use a nonlinear transformation. Nonlinear transformations are important because they tell us whether a linear model is appropriate or not. A scattered residual plot tells us that we are ready to proceed with the equation and all the assumptions have been met using the residual plot. There are four distinct transformations we must know in order to get a randomly scattered residual plot. First, you must enter the data into L1 and L2 in your calculator to create a residual plot. If it is not scattered, then we will enter our first transformation into list 3 and run the L1, L3 regression and to recreate the residual plot.
Now we're going to show you how to actually transform a residual plot. Let's begin by saying we are given a particular data set and we have entered the x values into L1 and the y values into L2. We will run the regression under StatCalc using option 8 with L1 and L2, and then turn on your stat plot. Make sure you use the second graph and it has L1 resid. Hit zoom 9 and you'll get your residual plot. Since there is a pattern, we need to transform the data. We do this by going back to the list and using L3 by highlighting it and typing in the first transformation equation, which is the log of y. Then you're going to rerun the regression using L1 and L3. Make sure your stat plot is on. For the second transformation equation, we will use the log of x. We will use the same data set for this example as the previous one, and we will begin by highlighting L4 and typing in the log of L1, since those are the x values. Then we will rerun the regression using L4 and L3. Make sure your stat plot is on using the same graph as before, and then create your residual plot. Now we're going to move on to the third transformation, which is the square root of y. So if we're given this particular data set and we run the residuals and the residual plot is still not randomly scattered, then we're going to move on to the square root of y. So you'll highlight L3, get your data points, and rerun the regression using L1 and L3. And then you turn on your stat plot. And then that's your residual plot. The fourth and final transformation equation is 1 over y. So for example, if we're given this data set, then we're going to create the residual plot using 1 over y. And you rerun the regression using L1 and L3. And then you turn on your stat plot, hit zoom 9, and you get your residual plot.
So continuing the lesson on nonlinear regression transformations, we're going to use this data set as another example. So if you go ahead and make the residual plot of this to check to see if a transformation is necessary, you're just going to go to second stat and then residuals, and then you're going to make a residual plot by going to your plots and make this, instead of list 2, list 3, then go to zoom 9 to get the plot. And as you can see, this plot clearly has a pattern, so that means we're going to need to make some sort of transformation to make this randomly scattered. So if you go back to your data sets, you're going to get rid of this list 3, and for the transformation we're going to use is actually not one of the 4 we've been given. This is going to be an example for using a different one, so something besides that one of the other equations you'd have to use. So the one that I found works the best is going to be if you cubed your list 1 or your x values. Just go to list 1 and then cube it, bring it down, and then you got a new set of x values. So then you're going to have to run another linear regression for, instead of list 1 and list 2, it's going to be list 3 and list 2. So go ahead and calculate that, and then after you get it, go back to your data sets, and in list 4 you're going to make the residuals of that, so second 7. So now you have your original x value, your original y value, then here is your x cubed, and right here is the residuals of x cubed and your original y value. So now we're going to make a residual plot of this. So going back to your plots, instead of list 1 we're going to have list 3, and instead of list 3 we're going to have list 4. Then go to zoom 9 to get the plot, and as you can see, it is now randomly scattered, so you can then continue on. All the assumptions for linear regression have been met, so you can continue on with your equation and you will be all good.
Good.
Alright, welcome back, class. We're at the stat garden here for the final time of this presentation. For those of you who forgot, this presentation was about nonlinear transformations, and you always use those whenever your residual plot is not randomly scattered. So whenever you're going through your equations trying to check for your assumptions or whatnot, just if the residual plot is not randomly scattered, you're going to have to use a transformation equation. And the whole point of these equations are that they tell us if your linear model data set is appropriate or not. And just a hint to remember whenever you guys do this is that to always start with the first equation. So you just kind of want to go in order of the equations, 1, 2, 3, and then 4. Just something to keep in mind whenever you're working these. It will help you get through this a lot faster. I hope you enjoyed the presentation.